What's going on, guys? It's Eric from Intelligent Quads. Today I'm going to be starting a whole new series, and in this series we're going to be going into the inner workings of Mavlink and how we can use Mavlink and Pymavlink to get data from our drone and send commands to our drone. So in previous videos, I've had you guys use the IQ GNC functions, and basically those are built off of Mavlink. But in order to generate those Mavlink messages, we use the package mavros, which converts ROS messages into Mavlink messages. So in this video series, we're going to be using the library Pymavlink, which is a lot lower of a library to generate Mavlink messages to send the commands that we were doing in the IQGNC functions. I think this will really help you guys out because sometimes you guys really need to know the underlying communication protocol to really debug some of the unintuitive problems that'll crop up when you're developing intelligent drone applications. So without further ado, let's get into the video. Alright, so in this video, I'm going to be showing you guys how we can write a program to listen to Mavlink messages. So the first thing we're going to need to do is install Pymavlink. So you're going to simply do that by opening up a terminal and doing pip3 install Pymavlink because we're going to be using Python 3. Boom, installing Pymavlink was as simple as that. So let's go ahead and create a folder for our programs. Now I'm going to cd into that folder and launch our text editor. Alright, so now that we got our text editor open, let's go ahead and create a file called listen.py. And in this program, we're going to basically create a Mavlink connection over UDP to a software in loop instance and get all of the telemetry data that's coming over Mavlink into our program, and we're just going to print it out in this video. In later videos, we're going to be doing more complex things with this connection link. So in this video, I'm going to be doing the very simple tutorial about listening to the Mavlink messages, which is in the MavGen Python part of the Mavlink documents. So if you want to follow along via that, the link will be down in the description. So I'm going to just go ahead and simply paste in all this code right here. And now I'm going to talk about it. So what we are doing is we're using a module called mavutil from Pymavlink, and the mavutil has a lot of helper functions for connections and sending messages. So what we're going to do is we're going to connect using the Mavlink connection function to localhost, and then we're going to change this to 14550.551. 550 is typically the default Mavlink connection stream, but when we launch the CITL, there are two Mavlink connection streams made, and we're going to be using the secondary one because we're going to be using the primary one for our ground control station just to monitor the state of the vehicle graphically and easily. So after the connection is established, we're going to call the function wait for heartbeat. And basically what's happening is the aircraft is always sending out heartbeats, letting the GCS and what other aircraft or program know that the aircraft is there, right? And the aircraft has the SysID, the system ID of that Mavlink node, as well as the component ID of that Mavlink device on the Mavlink system. So once we get the connection, we're going to print out what the target connection was and what the target component was. So now that we have the basis for the simplest Pymavlink program, we're going to go ahead and start the RDPilot CITL. So let's go ahead and go back to our terminal, and we're going to make a directory called drone so that all the CITL file artifacts end up in that folder. So now we'll cd to drone. And now we'll launch the RDPilot software in the loop by running simvehicle.py, and then we're going to put a -v and then rdocopter. pi, excuse me. So that'll go ahead and launch up our connection. You'll see a bunch of the initialization printouts happening. So up here, I'll like to point out that the mav proxy node is outputting a Mavlink stream on localhost, which is 120.0.0.0.1 and then 14550, and then also on localhost 14551. And we're going to be using the 14551 for the Python program, and then 14550 for Q ground control. So now let's go ahead and launch Q ground control, and we can see that way we can see the state of the vehicle. So my Q ground control is in downloads, so I'm going to go to downloads and then launch the app image of Q ground control. So Q ground control goes ahead and automatically connects to the CITL instance, and we can see the aircraft is sitting on this runway. So now that we have our CITL instance and Q ground control connected, let's go ahead and run our program and see what happens. So just for the convenience of running this program, I'm going to be using the integrated terminal within VS Code to run this program. So to do that, all you have to do is do control and then tilde, and then the integrated terminal will pop up right there. To run this program, all we're going to do is do Python 3 and then listen.py. And it looks like we found a heartbeat from system 1, component 0. All right, so now we're going to be getting the rest of the telemetry data from the vehicle. So now let's go back to the Mavlink docs, and we'll go down to the part about receiving messages. So down here, we're going to be looking for this command, this line, the message equals the connection.receive message blocking true. And basically what this is going to do is going to receive all of the messages available. So I'm just going to go ahead and put this in a while loop and set this equal to while true, and then put message equals the connection, receive matching, and then blocking equal true. And then we're just going to print message. All right, now let's go ahead and run this. So now we're getting tons and tons of data from the vehicle in our Python program. So I'm just going to show you guys one more thing before I end this video, and that is how to filter for a message. So say we want to filter for the attitude message. We are just going to basically take the same program that we have here and then set this type equal to the type attitude. And then now we should only be receiving the attitude messages and printing those out, which is now what we're getting. And now this is basically a Python dictionary, and if you want to adjust the role, you could basically index that straight from the message. So in this video, I just showed you guys how to install Pymavlink, set up a connection, and get data from your software in the loop vehicle. In the next video, I'm going to be showing you guys how to send commands to the drone and arm the drone. And then we're going to be getting into more and more complex topics about how the Mavlink system works and how you can use Pymavlink to send Mavlink. All right, so until next time, guys, keep it cool.